Sometimes we're given an equation in polar form and we want to be able to graph it, or we want to know what it behaves like, and we want to change it into a form that we're more comfortable and familiar with. And so we want to change it into rectangular form. Things in terms of x and y, things that we are more in, that we know better. So what can we do, and what do we know that would help us convert from equations in polar coordinates to rectangular coordinates? So before we start, polar coordinates, remember, have an ordered pair of r comma theta. So r is the distance that our point is from the pole, so it's this distance here. And then theta is the angle measure that it travels along. So what can we do in rectangular coordinates, which is x and y, or what do we know about things in polar that we can express in rectangular, and so on? So I just want to go through and kind of list all the things that we can use to try and convert between polar form and rectangular form. So this is a polar graph laid over Cartesian coordinate planes, the rectangular coordinates. So we have this right triangle here, and it's in terms of x and y, and also we have r and theta. So we know that r is just going to, the r squared, which is a hypotenuse here, is just x squared plus y squared using Pythagorean theorem. So that's one thing that we can use. So r squared equals x squared plus y squared. So if we're ever looking for something that's just in terms of r or in terms of r squared, we can always convert it into being x squared plus y squared. We also know that the x coordinate in polar coordinates is equal to r times the cosine of theta. We get that from saying the cosine of theta is x over r and then solving for x. We know that the y coordinate is just r times the sine of theta. Again, we take the sine of theta. Sine of theta is y over r, and solve for y. And if we are looking for something that's just in terms of theta and using just the measures that we know in rectangular coordinates, we can talk about the tangent. We could say that the tangent of theta is equal to y over x, the opposite over the adjacent. So y over x is equal to the tangent of the angle theta. And so these are some things that we can use to try and help us convert between polar coordinates and rectangular coordinates, or between an equation in polar form and change it into rectangular form, so that we can graph it or talk about its behavior, and just using something that we're more familiar with when compared to polar coordinates.